Welcome. Today you'll explore an in-place merging technique that simplifies your code and boosts your problem-solving skills. We're excited to have you with us. Introduction. Welcome to our exciting coding journey. In this session, you'll learn how to merge two sorted arrays directly in place. No extra memory needed. This approach not only makes your code more efficient, but also gives you the confidence to tackle more challenging problems. Every part of this guide is written with you in mind, ensuring each concept is clear and approachable. We're thrilled to be on this path with you. Let's dive in and enjoy the learning process together. Problem title: Mastering the Merge Sorted Array Challenge, a clear and practical guide. Get ready to learn how to seamlessly combine two sorted arrays into one, right within the original array, without extra space. We believe in your ability to master this challenge. Problem statement: Imagine you have two lists that are already sorted. The first list, nums1, includes extra zero placeholders at the end to accommodate additional numbers. The second list, nums2, contains its own sorted values. The variables m and n tell you how many valid elements are in nums1 and nums2 respectively. Your challenge is to merge these two lists directly within nums1 so that you end up with one completely sorted list, all without using any extra space or built-in sorting functions. Embrace the challenge, and remember that every line of code you write brings you closer to coding mastery. We're here to support you. Here's the challenge. Merge two sorted arrays into one without extra space. Trust yourself. You can do it. What is the Merge Sorted Array Challenge? This challenge is a fantastic opportunity to learn how to merge two sorted arrays into a single sorted array without using additional memory. You'll explore a method that rearranges the elements in place using smart pointer manipulation. Discover how to effectively use pointers starting from the back of each array. Merge the arrays without relying on extra storage space. Build an efficient algorithm to combine and sort your data in one go. This in-place merging technique is a valuable skill, especially when working with large data sets or limited memory. We're excited to see you apply these insights and grow as a programmer. Learn to merge two sorted arrays by modifying the original array directly. We're excited to take this journey with you. Step-by-step algorithm. Initialization. Begin by setting up 3 pointers. I equals m minus 1. This pointer targets the last valid element in nums1. J equals n minus 1. This pointer targets the last element in nums2. K equals m plus n minus 1. This pointer indicates the last index in nums1, where the next highest element will be placed. Merging. While both pointers I and j are within range, compare nums1 I with nums2 j. If nums1 is larger, place it at nums1 k and move I one position left. If nums2 j is larger or equal, place it at nums1 k and move j one position left. Always decrease k after placing an element. Finishing up, if there are any elements left in nums2, i.e., j remains non-negative, copy them into nums1 to complete the merge. All done. Once every element is in place, nums1 will be fully merged and sorted. Each step is a building block to your success. Trust the process and know that you're making great progress. This algorithm uses 3 pointers to compare and place elements correctly in nums1. Step by step, you're mastering in-place merging. Keep up the great work. Testing examples. Example 1. Input. Nums1 equals 1, 2, 3, 0, 0, 0. M equals 3. Nums2 equals 2, 5, 6. N equals 3. Expected output. 1, 2, 2, 3, 5, 6. Explanation. The elements from nums2 are merged into nums1 in the correct order. Example 2. Input. Nums1 equals 1. M equals 1. Nums2 equals N equals 0. Expected output. 1. Explanation. Since nums2 is empty, nums1 remains unchanged. Example 3. Input. Nums1 equals 0. M equals 0. Nums2 equals 1. N equals 1. Expected output. 1. Explanation. When nums1 starts with no valid elements, the single element from nums2 fills the space. These examples showcase different scenarios to help you understand how the merge operation works. Enjoy testing and learning from each example. You're doing an amazing job. These examples illustrate various scenarios for merging arrays. Each case reinforces your understanding. Keep pushing forward, you've got this. Merge function invocation. The merge function was called with nums1 equals 1, 2, 3, 0, 0, 0, m equals 3, nums2 equals 2, 5, 6, n equals 3. We are starting the in-place merge process with these arrays and their respective sizes. Keep going, you're doing great. You're off to a strong start. Pointer I initialization. Pointer I is initialized to 2, which is m-1, to point to the last valid element in nums1. This makes sure we start from the end of the valid numbers in nums1. Keep it up. Excellent work setting this up. Pointer J initialization. Pointer J is set to 2 in -1 to point to the last element of nums2. This allows us to traverse nums2 from the end confidently. You're doing amazing. Fantastic job positioning your pointers. Pointer K initialization. Pointer K is set to 5, which is m plus n-1, to indicate where the next element should be merged in nums1. This pointer marks the last available position in nums1. Keep pushing forward. Awesome. You're ready for the next step. Merge loop initiation. Checking merge conditions with pointer I at 2 and pointer J at 2. We will compare elements as long as both pointers are within valid ranges. Stay focused and keep up the great work. You're doing an excellent job initiating the loop. Merge loop iteration start. Comparing nums 1, 2 equals 3 with nums 2, 2 equals 6. Determine the larger number to continue building the sorted array. Fantastic job keeping track. Every comparison brings you closer to success. Element comparison. Comparing nums 1, 2, 3 and nums 2, 2, 6. This comparison ensures the next element is placed correctly. Wonderful work. Your analytical skills are shining through. Select from nums 2. Since 6 is less or equal, we take it from nums 2, 2 and place it in nums 1, 5. Choosing the element from nums 2 maintains the proper order. You're doing a fantastic job. Excellent alternative choice. Assign from nums 2. Assign 6 from nums 2, 2 to nums 1, 5. This assignment ensures the element is correctly merged. You're on the right track. Well done. This element is in the right place. Decrement pointer J. Pointer J has been moved to 1 after its element was placed. This step advances the pointer so that the next element from nums 2 is ready to merge. Great job. Excellent progress. Keep those pointers moving. Decrement pointer K. Pointer K is now 4, ready for the next placement. You're steadily placing each element in order. Keep up the fantastic effort. Every decrement is a win. Awesome work. Merge loop condition recheck. Rechecking merge conditions. Pointer I is 2, pointer J is 1. Confirming that both pointers are within range before continuing. Excellent dedication. Stay focused. Your attention to detail is paying off. Merge loop iteration start. Comparing nums 1, 2 equals 3 with nums 2, 1 equals 5. Determine the larger number to continue building the sorted array. Fantastic job keeping track. Every comparison brings you closer to success. Element comparison. Comparing nums 1, 2, 3 and nums 2, 5. This comparison ensures the next element is placed correctly. Wonderful work. Your analytical skills are shining through. Select from nums 2. Since 5 is less or equal, we take it from nums 2, 1 and place it into nums 1, 4. Choosing the element from nums 2 maintains the proper order. You're doing a fantastic job. Excellent alternative choice. Assign from nums 2. Assign 5 from nums 2, 1 to nums 1, 4. This assignment ensures the element is correctly merged. You're on the right track. Well done. This element is in the right place. Decrement pointer J. Pointer J has been moved to 0 after its element was placed. This step advances the pointer so that the next element from nums2 is ready to merge. Great job. Excellent progress. Keep those pointers moving. Decrement pointer K. Pointer K is now 3, ready for the next placement. You're steadily placing each element in order. Keep up the fantastic effort. Every decrement is a win. Awesome work. Merge loop condition recheck. Rechecking merge conditions. Pointer I is 2, pointer J is 0. Confirming that both pointers are within range before continuing. Excellent dedication. Stay focused. Your attention to detail is paying off. Merge loop iteration start. Comparing nums1, 2 equals 3 with nums2, 0 equals 2. Determine the larger number to continue building the sorted array. Fantastic job keeping track. Every comparison brings you closer to success. Element comparison. Comparing nums1, 2, 3 and nums2, 0, 2. This comparison ensures the next element is placed correctly. Wonderful work. Your analytical skills are shining through. Select from nums1. Since 3 is greater than 2, we take it from nums1, 2 and put it in nums1, 3. You chose the larger element from nums1, keeping the array sorted. Excellent choice. Keep it up. Brilliant decision making. Assign from nums1. Assign 3 from nums1, 2 to nums1, 3. This assignment correctly places the element in the merge array. You're doing awesome. Nice placement. You're making excellent progress. Decrement pointer I. Pointer I has been moved to 1 after placing its element. Every move brings you closer to a complete solution. Keep going. Each step counts. Great job moving forward. Decrement pointer K. Pointer K is now 2, ready for the next placement. You're steadily placing each element in order. Keep up the fantastic effort. Every decrement is a win. Awesome work. Merge loop condition recheck. Rechecking merge conditions. Pointer I is 1, pointer J is 0. Confirming that both pointers are within range before continuing. Excellent dedication. Stay focused. Your attention to detail is paying off. Merge loop iteration start. Comparing nums1, 1 equals 2 with nums2, 0 equals 2. Determine the larger number to continue building the sorted array. Fantastic job keeping track. Every comparison brings you closer to success. Element comparison. Comparing nums1, 2 and nums2, 0, 2. This comparison ensures the next element is placed correctly. Wonderful work. Your analytical skills are shining through. Select from nums2. Since 2 is less or equal, we take it from nums2 0 and place it into nums1 2. Choosing the element from nums2 maintains the proper order. You're doing a fantastic job. Excellent alternative choice. Assign from nums2. Assign 2 from nums2 0 to nums1 2. This assignment ensures the element is correctly merged. You're on the right track. Well done. This element is in the right place. Decrement pointer J. Pointer J has been moved to -1 after its element was placed. This step advances the pointer so that the next element from nums2 is ready to merge. Great job. Excellent progress. Keep those pointers moving. Decrement pointer K. Pointer K is now 1, ready for the next placement. You're steadily placing each element in order. Keep up the fantastic effort. Every decrement is a win. Awesome work. Merge loop condition recheck. Rechecking merge conditions. Pointer I is 1. Pointer J is -1. Confirming that both pointers are within range before continuing. Excellent dedication. Stay focused. Your attention to detail is paying off. Exit merge loop. Exited the merge loop with pointer states. I equals 1, J equals -1. This indicates that one of the arrays has been fully processed. Take a moment to celebrate your progress. Great perseverance. You're almost there. Remainder check for nums2. Now checking if there are leftover elements in nums2 at pointer J equals -1. This check makes sure all elements from nums2 are eventually merged. Keep up the thorough work. You're ensuring no element is left behind. Fantastic. Merge completion. Merge operation is complete. nums1 now contains a fully merged and sorted array. Your hard work has paid off. Great job finishing the merge. Keep shining and coding. Congratulations on completing this challenge. Time and space complexity analysis. Time complexity. O, m plus n. The algorithm processes every element from both arrays just once. Space complexity. O, 1. The merge is done in place using only a few pointers, so no extra space is required. Understanding how efficient your code is can inspire you to write even better algorithms. Keep up the great work. You're on the path to mastery. The algorithm runs in linear time and uses constant space, highlighting its efficiency. We appreciate your focus on these key concepts. Keep it up. Implementation hints. Tip 1. Begin from the end of both arrays to avoid overwriting important data in nums1. Tip 2. Use 3 pointers. One for tracking the last valid element in nums1, one for nums2, and one for the placement position in nums1. Tip 3. After the main merging loop, ensure you copy any remaining elements from nums2. Tip 4. Avoid built-in sorting functions. Managing the order manually reinforces your learning. Tip 5. Walk through each example step by step to see how the pointers adjust during the merge. Every hint is meant to build your confidence and guide you to success. Remember, each suggestion is a stepping stone on your coding journey. We believe in you. Keep these hints in mind. Compare from the back, manage your pointers carefully, and always check for leftovers. You're on the right path. Trust your skills. Why practice the Merge Sorted Array Challenge? This challenge is important because it helps you grasp array operations and pointer manipulation. Shows you how to modify data directly in place without extra memory. Sharpens your ability to design efficient and effective algorithms. Every time you tackle a new problem like this, you grow as a programmer. We're proud that you're investing in your skills and taking this step toward greater expertise. By working on this challenge, you deepen your understanding of array operations and in-place algorithms. Your commitment to learning is inspiring. Keep going. Key JavaScript concepts covered. Loops. Practice iterating through arrays with while loops. Conditional statements. Learn to use if-else conditions for decision-making. Array indexing. Understand how to access and update array elements. In-place operations. Master modifying an array without extra space. Algorithm design. Develop a clear plan for an efficient solution. Dive into these core concepts with enthusiasm. Each topic enhances your coding toolkit, and we're cheering you on as you grow and succeed. This challenge covers loops, conditionals, indexing, in-place operations, and algorithm design. Every concept brings you closer to being a coding pro. Keep up the amazing work. Real-world applications. Data merging. Efficiently combine sorted records or log files. Memory optimization. Save storage by merging in place. Crucial in resource-limited environments. Efficient data handling. Process large volumes of data faster with optimized techniques. This approach isn't just theoretical. It applies to real-life scenarios where efficiency matters. Every new skill you learn equips you to solve practical problems. We're excited to see you take on these challenges. The techniques in this challenge apply to real-world problems like merging records and optimizing memory usage. Your progress here is a testament to your potential. Keep striving for excellence. Final conclusion. Congratulations on completing the Merge Sorted Array Challenge. You've successfully learned how to merge two sorted arrays in place using pointers. This achievement not only reflects your technical skills, but also your determination to overcome challenges. As you add this powerful technique to your coding toolkit, take a moment to appreciate your hard work and progress. We're grateful to have been a part of your journey, and we look forward to seeing you continue to grow as a programmer. Keep coding, stay passionate, and always believe in yourself. Great job! You've mastered the Merge Sorted Array Challenge by effectively using pointer manipulation and in-place operations. We're proud of your progress and can't wait to see what you conquer next.